To make addition of these mixed numbers, the best way is add the whole numbers separately. 17 and 11 it is 28 and 6 it is 34, and add the fractional part separately. When we add these up, we get 10 upon 17. So the answer is 34 10 upon 17. There are 3 more variants of this type of addition, so we are discussing all these one by one. So here 15 and 6 21 and 2 it is 23. So when we add up 2 upon 13, 4 upon 13 and 7 upon 13, we get 13 upon 13. 13 upon 13 is equal to 1. So 23 plus 1 is 24. Now suppose here we have 12 upon 13. So again 15 plus 6, 21 and 2, 23. Now 12 upon 13 plus 4 upon 13 plus 7 upon 13, it gives us 16 and 7, 23. 23 upon 13. Now we will convert this number into mixed number. One whole number 10 upon 13. So again this one will be added to this. It is 24. 24 plus 10 upon 13, that becomes 24 whole number 10 upon 13. So when the numerator is bigger than the denominator, we will again have to convert it into mixed numbers and to make arrangement like this. To solve this problem, deduct 2 from 7 and we get 5. Now 11 upon 19 minus 15 upon 19, that gives us minus 4 upon 19. So we need to deduct 4 upon 19 from 5. Now borrow 1 from this 5. 4 plus 1. We have borrowed this one from 5. Minus 4 upon 19. So we need to solve this portion. 4 plus 15 upon 19. So answer is 4 whole number 15 upon 19. Now we can cut short the time taken in calculating this answer. How it is? Just deduct 1 from the whole number, it is 136. Now take the difference of numerator and denominator. Denominator minus numerator is 6. And write down the denominator as it is. So this is the answer. Now let us do some problems to understand the concept clearly. So 1 less than 49 is 48. 23 minus 17 is 6 upon 23. That is the answer of this subtraction. So 85. 27 minus 19 is 8 upon 27 is the answer. So 38. This minus this is 4 upon 117. So with the help of this technique, we can find out the subtraction of such problems very fast and very easily. I want to subtract 6, 5 087 from this number? The answer will be 6, 3, 4, 9, 1 and 3. This I have done with the help of Vedic mathematics. Vedic mathematics says that when a number is followed by all the zeros, here the number 7 is having all the trailing zeros. So if a number is followed by all the zeros, it is very easy to subtract any number from that number. First thing, we can do such subtraction starting from the left hand side, and secondly, we can find out the answer very easily in a very short time. Let us do this sum again to understand the process. So 7 and 5 times zeros, and we have to deduct 65087 from this number. Put a line over here where the zeros of the upper line are starting. This is our line number 1, this is line number 2, and the answer line is line number 3. Now subtract 1 from this number on the left hand side. When 1 is subtracted from 7, we get 6. Please note that we are always to subtract 1 from the number on the left hand side. Now forget all these zeros. We have to make the total of these two digits on the line number 2 and line number 3. We have to make the total of these two digits to be 9. So 6 and 3 9, 5 and 4 9, 0 and 9. It is 9, 8 and 1 9, and the total of last two digits to be made 10. 7 and 3 is 10. So all from 9 and last from 10. So adopting this method, we can subtract any number from a number having all the zeros very easily and very quickly. Now let us do some practice by solving these sums. So put a line over here, subtract 1 from this 8, it is 7, forget all these 0, put 0 over here. Now 0 and 9, it is 9, 4 and 5 is 9, 5 and 4 is 9, 9 and 0 is 9, and 7 and 3, it is 10. Put a line over here, subtract 1 from this 46, it is now 45, from 45 subtract these 2, it is 43, and 3 and 6 9, 1 and 8 9, 7 and 2 9, 0 and 9, it is 9, 6 and 4, it is 10. So we can solve such problems very easily with the help of Vedic mathematics. With a little practice, we can make our speed very fast. Suppose we want to deduct 4, 5, 6, 0, 3, 1 from this number. So 88, 1 deducted from 89. 88 minus 4 is 84. 4, 3, 9, 6 and 9 is the answer. We are going to start multiplication. Here we are going to learn how we can multiply a number with one digit numbers. In this case, we are going to multiply by 8, here by 7 and here by 6. The answer will be 80 plus 56, it is 136. 210 plus 63 is 273. 480 plus 54 is 534. So we have done the calculation with the help of mental math. Let us see how we can do that. 17 is equal to 10 plus 7. We are going to multiply this by 8. So multiply 10 by 8, it is 80. Multiply 7 by 8, it is 56. And when we add them up, it is 136. So the method is start multiplying from left hand side. In this 17, this is 10, this is 7. Multiply 10 by 8, it is 80. Multiply 7 by 8, it is 56. So our answer comes to be 136. So here it is 30. 30 multiplied by 7 is 210. 9 multiplied by 7 is 63. And when added, it is going to give us 273. 80 multiplied by 6 is 480. 9 into 6 is 54. And when we add them up, we are going to get 534. In the initial stages, we can work the multiplication like this. For example, 68 multiplied by 9 is 60 into 9, 540. 8 into 9, it is 72. So answer is 612. But after doing certain practice, we can directly calculate 480 plus 54 is 534. To make this total in the brain, what we can do? We can work like this. 80 multiplied by 6 is 480. 9 multiplied by 6 is 54. In 480, if we add 20, it will become 500. So from this 54, take out 20. This will become 480 will become 500, and after taking 20 from the 54, we will left with 34. So total will become 500 plus 34. It will become 534. So after doing a certain level of practice, we can very easily calculate such multiplications. The best use of making calculations with this method that we need not to learn tables beyond 9. If we learn the tables up to 9, we can make all the tables very easily. How? For example, we don't know 16 nines are. So it is 90, it is 54, so it is 144. We don't know 27 into 8, so it is 160, and 56, so it is 6, 1 and 2. So it is 180, it is 36, so it is 6, 1 and 2. So with the help of this method, we will be able to make the tables very easily with mental math or with the very high speed. Now let us move further. When multiplying a number with one digit number, and if the number is of more than 2 digits, for example, here we are multiplying one digit number with a 3 digit number, here by 4 digit number, and here by 5-digit number, then we are going to adopt a different method. Multiply 3 by 6, it is 18. Now we are left with 2 digits, so put 2 zeros over here. Multiply 9 by 6, it is 54, and we are left with 1 digit, so 1 0 and 54. Multiply 8 by 6, it is 48. Now it is very easy to make the additions. 2388 is the answer. Multiply 7 by 4, it is 28. We are left with 3 digits, so 3 zeros. Multiply 1 by 7 and we are left with 2 digits, so 2 zeros, and 1 by 7 is 7. Multiply 8 by 7 and 1 digit is left, so 1 0 and 56. Multiply 9 by 7, it is 63. So total is 3, 2, 3, 9 and 2. Multiply 5 by 9, it is 45. 1, 2, 3, 4, 4 zeros. Multiply 1 by 9 and 3 zeros. 3 zeros and 9. When we multiply 0 by 9, we get 0. So there is no use of writing 0 over here, so we can leave it. Now multiply 3 by 9 and 1 0. So 9 by 9, it is 81. So total is 1, 5, 3, 9, 5 and 4. So if we start multiplying from left hand side, we will be making our calculations faster and easier. The answer of this multiplication will be 36, 32 and 72 and 16. It is 88. So the answer is 2, 1, 5 and 4. The answer of this multiplication is 18, 32, 42. Then 24 and 56, it is 80. 16 and 36, it is 52. 2 crosses, 12 and 63, it is 75. So the answer is 2, 4, 15, 13, 14 and 2. So we can do multiplication this fast with the help of a new method. Let us see how it works. We are here multiplying a 2-digit number by another 2-digit number. So 2-digit number is being multiplied by 2-digit number. This is the first step, this is the second step. In the first step, we will multiply first by first, first by first. The first step can also be taken from the left hand side. We can start from here. In the second step, we will cross multiply first and second with 1 cross. So the first step is 7 multiplied by 9, it is 63. 5 multiplied by 6, it is 30. Now put 1 cross. In the second step, 9 multiplied by 5, 7 multiplied by 6, total is 87. So put 87 over here, add it up, and the answer is 7,200. While following this method, we need to keep in mind one thing, that is, suppose we want to multiply 96 by 21. So 9 multiplied by 2, it is 18. 6 multiplied by 1, it is 06. Please note that we will not take a 1-digit number. If we get a 1-digit number, we will make it a 2-digit number by prefixing 0 before that. So it is 12 and it is 9. So it is 21. And 6102 is the answer. In this method of multiplications, we are frequently adding two 2-digit numbers. For example, 27 and 68. To make the things easier, we can add the numbers from the left hand side. 27 is 20 plus 7. 68 is 60 plus 8. So this is 80. This is 15. So total is 95. Now suppose we want to add 29 and 93. So start from the left hand side. 20 plus 90 is 110. 110 plus 12 is 122. 87 and 46 is 120 plus 13, 133. 47 and 29 will be 60 plus 16. It is 76. 28 and 47 will be 60 plus 15 is 75. We can add the numbers from the left hand side. It will make the things easier. Now let us multiply these two 3-digit numbers. So first step is multiply first. The second step first, second with one cross, and in the third step first and third with two crosses. It is very easy to understand. In the first step first. In the second step first, second. In the third step first, third. So in the first step 4 by 7 is 28, 8 by 8 is 64, and it is 63. In the second step 72 and 56, it is 128. Please note that we will take only 2 digits, neither more than 2 nor less than 2. If we are getting less than 2, we will make it a 2-digit number by prefixing a 0 before that, and if we get a 3-digit number, we will take this 28 over here, and 1 is carried over. Now 8 sevens are 56, it is 32, it is 88. This carry is added to this 88 and it becomes 89. So 89 over here. Now 2 crosses, 7 multiplied by 9, it is 63, 4 by 7, it is 28. So 80 and 11, it is 91. So the answer is 3, 14 and 8, 24, 18 and 3. This method can be extended beyond 3 digits. So in the first step it is first. In the second step first, second with one cross. In the third step first, third, next first, third with 2 crosses, and in the fourth step first, fourth with 3 crosses. So the first step will be 9 by 4, it is 36, 9 by 8 it is 72, 0 by 8 it is 2 zeros. Please note, in this method we will be taking only 2 digits, neither more than 2 nor less than 2. So 7 by 7 it is 49. So similarly we will follow these steps and we will come to the answer. Now one more thing, we want to multiply 487 by 29. So when the digits are not equal, put a 0 over here. Now we have a 3-digit number multiplied by another 3-digit number, and now we can follow the same method to do our multiplication. We want to multiply these numbers by 11. So take 4 over here, 3 over here, add these two, 4 plus 3 is 7. Put 7 over here. 473 is the multiplication of 43 and 11. Take 5 over here, 7 over here, 5 plus 7 is 12. We can place only one digit in the middle, so 2 over here and 1 is added to this 5. So 627 is the answer. When the digits are more than 2, then we are going to follow a different method. Just below this number, write the same number, shifting the number to the left side by one digit. 6, 8, 9. Add it up, 9, 17, 15 and 7. Write the same number by shifting the number by one digit towards the left. 4, 7, 9, 6, 8. Add it up, 8, 14, 16, 17, 12 and 5. So this is the fastest method of multiplying any number by 11. There is a better way of multiplying a number with 5, 25, 125 and 75. Suppose we want to multiply 48 by 5. Take out a 2 out of this 48. 48 can be written as 24 into 2. So 2 into 5 will give us 10. So 24 into 10 is 240. We can also use this method to find out the multiplication of the numbers which are ending in 5. So try to take out a 2 out of this 18. 45 into 2 into 9. So 90 into 9 is 810. Now to multiply a number with 25, try to find out a 4. For example, 64 into 25. So to take out 4 out of 64, 16 into 4 into 25. So this is going to give us 100. So answer is 1600. Similarly, if a number is to be multiplied by 125, try to find out an 8. For example, 88 into 125, it is 11 into 8 into 125. This will give us a 1000. So the answer is 11,000. Similarly, if we are multiplying a number by 75, again try to find out a 4. For example, we want to multiply 64 by 75. So it is 16 into 4 into 75. This portion will give us 300. So 300 multiplied by 16 is 4800. The solution of this problem is 28, 27, 287, 527 is the answer of this problem, and here it is 56, 12, 560, 580, 12 is the answer of this problem. When we have zeros as the middle digit of a 3-digit number or a 4-digit number, then we can find out the solution without doing many calculations. Let us see how we can do that. In case of 3-digit numbers, there will be 3 different variants of such problems. So let us discuss all one by one. 7 by 8 it is 56, 3 by 4 it is 12, 8 by 3 24, 7 by 4 28, so 52. Place this 52 in the middle. Now 8 by 6 48, 3 by 2 06. Please note that we will be taking 2 digits. So 18 and 16, 34. In the middle, here it is 72, 56, 63, 64. 127. So 127 will be like this, 127. So the final answer will be 7325756. Similarly, in case of 4-digit numbers, there will be 3 different variants. So 32, 48, 48 and 32. So 80. So place 80 in between and 10 on the left and 10 on the right. It is 56, 09, 8 and 63, 71. 71 in the middle, 10 on the left and 10 on the right. 72, 56, 72, 56. So 128. We have got a 3-digit number. So 28 in the middle, 10 on the right, and in case of left 0, put this 1 over here, and this will be the answer. To take the square of a number ending with 5, just take square of 5, it is 25. Add 1 in this 6, it is 7. Multiply 7 by 6, it is 42. So 4225 is the square of 65. To take the square of 85, 25, multiply 8 by next number 9. 8 by 9 is 72. So 95 whole square is 25. 9 multiplied by 10. So it doesn't stop anywhere. So the square of 995 is 25. Multiply 99 by 100. 9900. So square of this number will be 25. 9999 multiplied by 10,000 plus 1. So it is 4 times 9 and 4 times 0. The square of 125 whole square will be 25, 12 multiplied by 13. So 156. Square of 195 whole square will be 25, 19 multiplied by 20, 380. Square of 295 will be 25. This is multiplied by 30. So 870. So it is very easy to find out the square of any number ending with 5. In the previous video, when we were taking square of 65, we were multiplying 65 by 65, 95 by 95, 9995 by 995, 125 by 125. So there was a pattern. The right hand side total was 10 and the left hand side was common. Right hand side digits total was 10 and left hand side common. Total 10 and common. Total 10 and common. So if this pattern occurs anywhere else, we can use the same method to find out the multiplication. For example, 68 multiplied by 62. Here the total of the right hand side digits is 10 and left hand side figure is common. So multiply 8 by 2, it is 16. Multiply 6 by next number 7, 42. So multiplication of 68 and 62 is 4216. The multiplication of 127 and 123 will be, here the total is 10. So it is 21, 12 multiplied by 13, 156. So 9996 multiplied by 9994, total is 10 and left hand side common. So 6 multiplied by 4 is 24. 999 multiplied by 1000 will give us 3 times 10 and 3 times 0. So we can extend the formula to find out the multiplications of the numbers where the total of the last digits is 10 and the left hand side is common. To take the square of any two-digit number, for example 79, we can make the square with the help of all these three digits 7, 9 and 2. Take the square of 7, 49. Take the square of 9, it is 81. Put a cross over here and multiply 7, 9 and 2. 7 9s are 63, 63 2s are 126. So 1, 4, 12 and 6 is the answer. The only thing to be kept in mind is take the square of 8, it is 64. Take the square of 3, it is 9. So it should be taken as 09. We have to take two digits. So it is 09. Now a cross over here. 8 3s are 24, 24 2s are 48. So 9, 8, 8 and 6 is the answer. Now let us do some practice with the square of any two-digit number starting from 11 to 99. Now square of 4, 16, square of 9, 81, 1 cross, 4 9s are 36, 36 multiplied by 2, 72. So 1, 0, 4 and 2. Now with practice we can enhance the speed of calculation. How it is? 25, 49. Cross. Now just take the multiplication of these two and double that. 5 7s are 35. Double of 35 is 70. So 9, 4, 2 and 3. 8109. 27 double is 54. 9, 4, 6, 8. 1601 double of 4 is 8. 1, 6, 8, 1. And we can take square of any number. For example, 67 whole square is 36, 49. 42 double is 84. So 9, 8, 4, 4. 13 square is 0, 1, 0, 9 and 6. So 1, 6, 9. So we can take the square of any two-digit number very easily with the help of this efficient method. If the numbers are near the base of 10, 100, 1000, 10,000 and so on, then it is very easy to take the square of such numbers with the help of Vedic math. The square of this number is 100,280,196. The square of this number will be 974,169. We can find out the square of such numbers with the help of mental math. How it can be done? Let us see. Suppose we want to take the square of 108. This is a number which is near to the base 100. So it means we are going to multiply 108 by 108. In 100, add 8 and 8. 8 plus 8, it is 16. Now multiply these two numbers again. 8 multiplied by 8 is 64. Place 64 over here and we get the answer. Now suppose we want to have the square of 102. So in 100 add 2 and 2, it is 4. 100 plus 4 is 104. Now multiply 2 by 2, we get 4. Please note that after doing this addition, the number of digits of the multiplication must be equal to the number of zeros in the base. We have 2 zeros in the base, so the digits in the multiplication must have two digits. So we will make it two digits. It will be 04. So answer is 10404. The answer of 101 whole square will be in 100 add 2. Multiply 1 by 1, it is 01. Multiplication of 117 will be in 100 add 17 and 7, it is 34. The multiplication of 17 and 17, it is 289. We are getting here 3 digits. So, but we are permitted to have only 2 digits in the multiplication. So, this 289 will be adjusted like this, 289. So, answer is 13689. So, the answer of 119 whole square will be in 100 add 19, it is 38. 19 multiplied by 19 is 361. So 361 will be adjusted like this. So answer will be 14161. Now let's come to this digit. Now we want to take the square of 987. This is near the base 1000. This number is 13 less than the base 1000. So deduct 13 from 987 and we get 974. Now multiply minus 13 by minus 13 and we get plus 169. This is a 3-digit number and there are 3 zeros in the base. So whole of 169 will be written over here. The number of digits of multiplication will be exactly equal to the number of zeros in the base. Now suppose we want to take the square of 98. So this is near the base 100. So this is 2 less than the base. So deduct 2 from 98 and we get 96. Multiply 2 by 2, it is 4. There are 2 zeros in the base, so it will be 04. So answer of 98 square will be 9604. So with the help of Vedic math, we can very easily find out the square of all such numbers. Now let us solve this sum. So 10,014 is multiplied by 10,014. In 10,000 add 14 and 14, it is 28. Now multiply 14 by 14, we get 196. In 10,000 we have 4 zeros. So this number should be of 4 digits. To make it a 4-digit number, we will put a 0 over here and the answer will be 0196. So the answer of this square is 100280196. Perfect squares are the numbers for which if we take the under root of such numbers, they come out to be whole numbers. Now I am writing 47672 and 78446. These two numbers are not perfect squares. Just by observation, I can say that these numbers are not perfect squares. When we will taking the square root of these numbers, we will not getting the whole numbers. To acquire this skill of learning whether a particular number is a perfect square or not without doing actual calculation, just with the help of our observation and mental math, we need to learn the properties of perfect squares. The first property of a perfect square is a perfect square never ends with 2, 3, 7 or 8. It means the last digit of a perfect square can never be a 2, a 3, a 7 or an 8. Now see this explanation. If we take the square of a number ending with 1, we are going to get 1 as the last digit of its square. And if we square a number ending with 2, we are going to get 4 as the last digit of the square. In case of 3, we are going to get a 9. In case of 4, we are going to get a 6. Here we will get a 5. Here 6. Here 9. Here 4. And here in case of 9, we are going to get a 1. So in the last digit of all the squares, we are not getting any 2, 3, 7 or 8. Now take for example 4, 7, 7, 7, 6, 4, 7, 7, 7, 1, 4, 7, 7, 7, 2 and 4, 7, 7, 7, 4. Suppose we have to find out which of the following cannot be a perfect square. The number ending with 2 can never be a perfect square. I have written all these numbers randomly. I don't know whether these are perfect square or not. These 3 may be or may not be perfect square. But about this number, I am pretty sure that a number ending with 2 can never be a perfect square. The second property of perfect squares is a perfect square never ends with odd number of zeros. Means if a perfect square is ending with zeros, the number of zeros should be 2, 4, 6, etc. etc. It shouldn't have the zeros in the odd number. Means there shouldn't be 1 0, 3 zeros, 5 zeros and so on. So this number is ending with 1 0, so it cannot be a perfect square. This number is ending with 3 zeros, so it cannot be a perfect square. These numbers, 2 numbers can be perfect squares. This is incidentally a perfect square of 50. About this number, we need to calculate whether this is a perfect square or not. But about these 2 numbers, we need not do any calculation. Without doing even a single calculation, we can say that 250 and 25,000 cannot be perfect squares because these 2 numbers are ending with odd number of zeros. Now next feature of perfect squares. For a number to be a perfect square, see the last digit. If the last digit is a 6, then second last digit of the number should be odd number. When the last digit is 6, the second last digit should be an odd number. It means 546 cannot be a perfect square. The last digit is 6, but second last digit should be an odd number. If the last digit is not a 6, then second last digit should be even. It should be an even digit. If the last digit is not a 6, then second last digit should be an even digit. It means 635 can never be a perfect square because last digit is not 6, then second last digit should be an even digit. Now the last property of a perfect square is for a number to be a perfect square, see the last digit. If the last digit is an even number, then last 2 digits should either be 2 zeros or should be divisible by 4. Here all the last digits are even numbers. So the last 2 digits should be either 2 zeros or the numbers should be divisible by 4. It means 47676 and 47674, which can be a perfect square. This number can be a perfect square. The last digit is an even number and the last two digits are divisible by 4. Here the last two digits 74 are not divisible by 4, so this number can never be a perfect square. For this we will have to check whether it is a perfect square or not. For this we don't have to check because the last two digits are not divisible by 4. In the last video, we have discussed the concept of perfect squares. Now we are going to discuss a method of taking square root of perfect square without doing many calculations. For example, we want to find out the square root of 529. 529 is a perfect square and we want to take its under root. Separate out last two digits. These two digits will give us the last digit of the square root and the left hand portion will give us the remaining part of the square root. To get a 9 as the last digit of any number, we will have to multiply either 3 by 3 or 7 by 7. So the last digit of the under root will be either 3 or 7. Now on the left hand side we have 5. 5 comes between 4 and 9. It means 5 is coming between the square of 2 and the square of 3. Take the smaller number 2. It means this will be a square of either 23 or 27. Now to find out the exact figure which one of these two is the under root of this number, multiply 3 by 2. It is 6. Now compare 5 and 6. If our number is smaller of these two, then smaller will be the answer. If our number will be bigger of the two, then bigger will be the answer. In this case, our number 5 is smaller than this number. So, smaller number, that is 23, is the under root of 529. Now, we want to find out the under root of 1444. Separate out last two digits. We can get a 4 either multiplying 2 by 2 or 8 by 8. So the last digit of the under root will be either a 2 or an 8. Now 14 is between 9 and 16. It means square of 3 and square of 4. Take the smaller number. So the under root will be either 32 or 38. To find out the exact number, multiply 3 by 4. It is 12. Now compare our number and this number. Our number is bigger than this number. So bigger number out of these two is the under root of 1444. So 38 is the under root of 1444. Now let us find out the under root of this perfect square. Separate out last two digits. We can get a 6 either multiplying 4 by 4 or 6 by 6. So either a 4 or a 6 is the last digit of its under root. Now 384 is coming between 361 and 400. It means the square of 19 and square of 20. Take the smaller number 19. So this number is a square of either 194 or 196. To find out the exact number, multiply 19 by 20. It is 380. Our number is bigger than this number, so bigger is the answer. It means this is square of 196, or 196 is the under root of 38,416. With a little practice, we can cut down our rough work time. So to find out the answer of this number, we can get a 9 either by 3 or by 7. So 53. 53 means 49 and 64. It means 7 and 8. So we are taking the smaller one, 7. It is either 73 or 77. Now multiply 7 by 8. It is 56. Our number is smaller than this number. So smaller. 73 is the under root of this number. Now coming to this, we can get a 1 out of 1 or 9. Now 146. 146 means 12 and 13. Square of 12 and square of 13. So we are taking the smaller one, 121 or 129. When we multiply these two, it is 156. So our number is smaller than this number, so smaller 121 is the under root of this number. So with the help of this method, we can find out the squares of numbers up to 40,000, because I am assuming that we are going to learn the squares up to 20. To take the maximum benefit of this method, we must memorize the squares up to 20. We want to find out the value of under root of 0.4. Let us find out the best way of solving this problem. For the numbers which are not starting with decimal, we make the pairs starting from right hand side. So first pair is 25, second pair is 56, and we start with 1. And by doing this, we move on further. Now we are going to take the same number starting with decimal. Now this number is starting with decimal. The best method of solving the numbers starting with decimal, start making pairs from the left hand side. First pair is 15, second pair is 62, third pair is 50, next pair is 00, and so on. As the number is starting with a decimal, we can add as many zeros as we need. So we are starting with 15. A decimal over here. 3 3s are 9, 6, taken down 62. So it is 6. It will go by 9. So 69 multiplied by 9 is 540 plus 81. It is 621. So it is 1, 4, 50 is taken down. So it is 78. 78, it will be around 5. So 78, 5 is then multiplied by 5 is 3500, 400 and 25. So 39, 25, and the answer will be around 0.395. And similarly, when we solve this problem, we will do like or 0, 0, 0, 0, 0, 0. We can put as many zeros as we need. So point over here 6, 36. So 4, 0, 1, 2, and it will be around 3. So 3, 6 and 9, and the answer will be come around 6 point, and the answer will be around 0.632. Similarly, if we want to take the under root of 0.121, the answer will be like 12, 10, 0, 0, 0, 0. So we will be starting with 12. So to solve the problems of the numbers starting with the decimal, the best method is start making pairs from the left hand side. Now let us find out the rule of divisibility of number 7. For the sake of convenience, we have chosen all these numbers which are already divisible by 7. The process is separate out last 3 digits. Now we have two numbers 398, 912 and 192. This is a bigger number, this is a smaller number. From the bigger number, subtract the smaller number. So 0, 2, 7, 3, 9, 8. Repeat the process and separate out last 3 digits. From the bigger number 720, subtract the smaller number 398, and we get 2, 2 and 3. So if this 322 is divisible by 7, then this whole 9-digit number will also be divisible by 7. Now let us come to this problem. Separate out last 3 digits. From the bigger number, subtract the smaller number. So 1, 7, 8 and 3. Repeat the process. From 871, subtract 3. So it is 868. If this 3-digit number is divisible by 7, then this 7-digit number will also be divisible by 7. Now here the first 3 digits are equal to last 3 digits, and when we subtract we get 0. Here when we subtract 8 from 22 we get 14. 14 is divisible by 7, so 8022 is also divisible by 7. The rule is, if in the end we get either a 0 or a number which is divisible by 7, then the original figure is also divisible by 7. Now, how we can find out that this 3-digit number is also divisible by 7? There is a very simple method. Just think of a number which is near to this number, and that number should already be divisible by 7. The number we think of should be near to this number, and that number should be divisible by 7. In my mind, 350 is a number which is divisible by 7. So from 350, just deduct 320 and we get 28. As 28 is divisible by 7, so 322 will also be divisible by 7. Here also we can do the same. From 868, first we deduct 700, because 700 is divisible by 7, so it is 168. For 168 we deduct 140. 140 is divisible by 7, so 28. As 28 is divisible by 7, so 868 will also be divisible by 7. So with the help of this method, we can very easily find out whether a number is divisible by 7 or not. Now we are going to find out the rule of divisibility of the number 13. The rule of divisibility of number 13 is very similar to the rule of divisibility of 7. Again, we are to separate out last 3 digits. From the bigger number, subtract the smaller number. So we get 906102. From 609, subtract 102 and we get 507. If 507 is divisible by 13, then this 9-digit number is also divisible by 13. So from 8514 we subtract 831. So it is 3, 8, 6 and 7. Subtract 7 from this one and we get 676. If this 3-digit number is divisible by 13, then this number is also divisible by 13. Here the numbers are same, so we are getting a 0. This number is divisible by 13. Here when we deduct 4 from 30, we get 26. 26 is divisible by 13, so 4030 is also divisible by 13. Now to see whether 507 is divisible by 13 or not, think of a number very near to this number which is already divisible by 13. Very simple number. In my mind comes 520. 520 is divisible by 13. So from 520 deduct 507, we get 13. As 13 is divisible by 13, so 507 will also be divisible by 13. Here again we can find out a number. In my mind comes 650. So when we deduct it, we get 26. 26 is divisible by 13. So this number is also divisible by 13. Now one very interesting thing about 6-digit numbers which have first 3 digits equal to the last 3 digits. 521, 521, 626, 626, 101, 101, 102, 102, 743, 743, 876, 876. All the 6-digit numbers which have first 3 digits equal to last 3 digits, these numbers are divisible by 7, 11 and 13. All these numbers are always divisible by these 3 numbers 7, 11 and 13.